Hello, welcome back. In this video, I'm going to be going over 3 ACT math questions. For all these problems, I recommend pausing the video first and trying the problems yourself before you see me solve them. Without wasting any time, let's get into it. Question 23 says, given y equals x over x minus 1 and x is greater than 1, which of the following is the possible value of y? So for this question, I would just start by plugging in numbers for x and try to identify a pattern. So let's plug in x equals 2, right? If we plugged in x equals 2, then the value of y would be 2. Now let's plug in x equals 3. And remember, we're looking for a pattern. If I plug in 3, I get 1.5, right? Now, if I plug in x equals 4, let's go a bigger number actually. Let's say I plug in x equals 100. Y equals 100 over 99. And 100 over 99, that is 100 over 99 is 1.0101 repeating. So the pattern to notice here is that whatever we plug in for x, right, the value of y, it is always greater than 1. And that makes sense, right? Because for your numerator is always going to be bigger than your denominator, as x minus 1 makes your denominator smaller than your numerator. As you can see here, your numerator is always bigger than your denominator, which means the value of y is always going to be greater than 1. So in our answer choices, let's just look for an answer that is greater than 1. It's not A because it's negative, and a negative number is not greater than 1. It's not C or it's not D, which means it's E. So just to summarize, for this problem, all I would do is just plug in numbers and try to identify a pattern. Question 50 says, for whole numbers x and y, the list below has 4 as its mean, median, and mode. What is the value of xy? So for this question first, let's focus on the mode part. If I look at this list, it says the 4 is the mode, but the mode is the most frequent number that appears in the list. But here, 2 appears once, 6 appears once, 4 appears once, and 1 appears once. 4 is just like the others, it only appears one time. If you want 4 to be the mode, that means that x or y, they have to be 4, right? One of them has to be 4 in order to make 4 the mode of the list. So let's just say x equals 4, okay? So now our updated list is 2, 6, 4, 1, 4, y. And remember, even if you pick instead of x equals 4, we picked y equals 4, it really wouldn't make a difference because we're figuring out the product of xy, right? And xy is the same thing as y times x. It really doesn't matter what you set, if you set x equals 4 or y equals 4. So now let's solve for y. So it says the list below has 4 as its mean, median, and mode. So we can actually solve for y using the mean. So remember, to find the mean, you add up everything in the list and you divide by the total numbers. So in this case, you're going to add up 2, 6, 4, 1, 4, and y, and divide that by 6 because there are 6 numbers. So let's do that. 2 plus 6 plus 4 plus 1 plus 4 plus y all over 6 equals 4. And now we can just solve for y, right? Let's multiply this side by 6. And let's simplify the numerator. 2 plus 6 is 8. 8 plus 4 is 12. 12 plus 1 is 13. 13 plus 4 is 17. So that becomes 17 plus y equals 24. And 17, we get y equals 7. Right? And now it's asking us for the value of xy. 4 times 7, which is 28. Also, we can check that this is right by testing if 4 is the median. Remember, to find the median, you have to just set up the list in increasing order. So 1 is the smallest number, then it's 2, then it's 4, then it's 4 again, then it's 6, and then it's 7. And if we were to try to find the median, indeed, the median is the number between the midpoint between the two middle numbers, and the midpoint between 4 and 4 is 4. So this proves that this is correct. So 4 times 7 is 28. On to the last question, which says, 57 says, the digit in the ones place of 2 raised to the power of 88 is 6. And it says, what is the digit in the ones place of 2 raised to the power of 90? So for this question, let's start listing powers of 2, starting with 1. And let's try to identify a pattern. So let's start with 2 raised to the power of 1, which is 2. And pay attention to the ones digit. So in this case, the ones digit is 2. For 2 raised to the power of 2, it's 4. 2 raised to the power of 3, it's 8. 2 raised to the power of 4, it's 6. Right? Because 2 raised to the power of 4 is 16. The ones digit is 6. Let's keep going. 2 raised to the power of 5 is 32. Notice that the ones digit is now 2. 2 raised to the power of 6 is 64. Notice the ones digit is 4. 2 raised to the power of 7 is 128. 2 raised to the power of 8 is 256. So you notice that it follows a pattern 2, 4, 8, 6, which means 2 raised to the power of 9, the ones digit will be 2. 2 raised to the power of 10, it will be 4. 2 raised to the power of 11, it will be 8. And then 2 raised to the power of 12, it will be 6, right? So now, obviously, I could just list, I could just continue this and eventually make my way to 2 raised to the power of 90. But instead, the thing to just notice is that every multiple of 4, so 2 raised to the power of 4, the ones digit is 6. 8, which is a multiple of 4, the ones digit is 6. And then same with 12, the ones digit is 6, right? And they've given us that 2 raised to the power of 88 is 6, and 88 is a multiple of 4, right? And we know if it follows the pattern 2, 4, 8, 6, 2, 4, 8, 6, this means that 2 raised to the power of 89 is going to be 2 again, right? And then 2 raised to the power of 90 is going to be 4, because it's going to follow, after 6, it's going to follow 2, 4, 8, 6 again. And then after 6 again here, it's going to go back to 2, 4, 8, 6, right? So, which means the answer is C. And yeah, for these types of problems, you should always just try to find a pattern by listing out like the first few powers. I hope that makes sense, and thank you for watching.